This is Jupyter Notebooks, and I'm going to give you a quick tutorial on how to get started in this. And I'll be honest, I'm not an expert. I'm not an expert at Python even. I've been doing it for a long time, and I can do what I can do. So let me show you the way I've done things in the past, and then I'm going to show you a quick introduction to Jupyter Notebooks. And this is just for myself because the best way to learn things is to explain things. There are much better videos out there that go over much more detail, and I don't even know everything. But let's just get started together. So let me skip over here to the other way I do Python. So Python, if you're not familiar, it's a language that's pretty popular. It's pretty easy to use. I really like this GlowScript v Python. It is built, this is in Trinket, so there's a couple ways to use it. This is in Trinket. This is all the code for a damped harmonic oscillator right there, and a graph output, and I think that's great. What I like about Trinket is that you don't have to install anything. It runs in a browser, it runs on a phone. You can easily share code. You don't have to worry about all this installation stuff. And I think that's great. And this has great graphing. It has great vectors. It has 3D animations. It's really great. But it doesn't have everything. Okay, there's some things like symbolic manipulations in Python, some other modules in Python that we can't use here. And so for more powerful stuff, we have to do something else. So I want to try to reproduce most of this, just the motion of a damped harmonic oscillator. And there's some very important differences to the way you do things in GlowScript v Python and actual Python. So this is actual Python. Okay, so the first thing is, how do you get this dumb thing running? Well, here is an application called Anaconda. So you can download Anaconda, and it will install most of the stuff for you. And then once you do that, you can just click this Launch Jupyter Notebook, and it will open a browser like this, and you'll get a Jupyter Notebook. And so this is, when I first started doing Python, you would have Python installed on your computer. You would import some modules and install some modules, and you'd write it in a text window and then run it, and that worked fine. This has some really nice advantages in that it's more like working in a notebook. So let's just get started. And I want to make that same thing, but I'm going to give you some other details in here. So the first thing I can do is name it. So let's say sample damped oscillator. I don't know. Rename it. One of the key things about Jupyter is this idea of cells. So you have these different cells where you can put codes, code blocks, or other things. So right here, I can just say, So if I click on this, now one of the things here, this can be green, means you can edit it, but blue is not editable. Okay, so if you click in the window right there, you can switch to edit mode. And I'm just going to say something like x equals 1, and then that's it. And then if I want to add another cell, or if I want to add a cell, I can press A. Once I'm right here, it will add a cell above it. And B, and I click this one right here, will add a cell below it. And then X will delete the cells. Okay. So that didn't do anything. I just wrote some code. I can actually run that. I can run that line by, you can click up here, you can click run. Is this big enough? Or I can press Shift Enter. And so it ran it, but nothing happened, right? Because I never told it to do anything. It ran the code, but that was it. So now down here, I could have another line. I could say print X. I'm going to run that one. And see, that one outputted it. Actually, I told it to print X, so it did. It printed X was 1. And if I go up to here and I change that cell, and then I go down here and rerun this, Shift Enter, it still does 1. Because I never ran this cell up here. I got to rerun that if I want to change it. So I'm going to rerun that, and then I'm going to rerun that, and then it gives me 2. Is this confusing? Yeah, well, we're going to do that in just a second. Now, there's a really great thing in Jupyter in that I don't have to just have code blocks. I can have text blocks. So if I press when it's in blue, I press M, it turns into a markdown cell. So now I can say, this is some stuff. Here is a list. Thing 2, thing 3. Now I run this, and it uses Markdown code. So if you're not familiar with Markdown, there's some. It's pretty easy just to type stuff and do some Markdown. But here's also a really cool thing. If I do this, Shift, oh no, not Shift M. If I just do, I gotta have this as blue, and type M. Now another Markdown code. If I do this, vec f net equals frac delta vec p delta t, and I run this. Oops, I had an error. Vec, no, I need to do vec math rm, and then run that. There you go. I can do LaTeX equations in here, which is, I think, really nice. If you want to like really work out and keep notes and stuff like that, you can put these equations in there. I'm going to go ahead and give you a link. Let me get this over here to a tutorial I wrote. Let's see, what's it called? Yeah, quick start guide. Let's see if this works. Okay, so if I copy this and I'll do over here, and then I'm going to press return, and then LaTeX. If you're not familiar with LaTeX, it's not a big deal. And then, I can put this to, you don't have to spell it right, but now I'm going to put this in. I know Markdown, because I use Markdown for other things, in a square bracket and then a parentheses like that. And now I run it, and I get a link. And there's my tutorial. Okay, but I'll include that link down below too. Okay, let's get started with the actual stuff. I'm going to delete this cell because I don't really want it. X deletes, X deletes. If you don't remember, you can go up here to cell, insert, view, edit, cut cells, X, copy cells, paste cells above, paste cells below, merge cells, everything. There's shortcuts if you want to go fast. You don't need to know those. Widgets, I'm not sure what that is. Kernel is in case you get something that stops, you can stop the code and rerun it. File, open new notebook, save. Again, you can tell I don't know what I'm talking about here. Oh, this is really nice. So we're going to use a couple of modules. And so that's the first thing I'm going to do. One of the things in Python is this ability to import modules. So I'm going to say the following. Let me show you something that doesn't work. Let's say if I want to take the sine of theta. So I can say theta equals 0.2, and then a equals sine of theta. And then I'm going to say print a. Now I'm going to run that. It doesn't work, right? Because it doesn't know what sine is. So I need to import a module that has all those mathematical functions in it. So I'm going to say import numpy. So I'm call it numpy. You call whatever you want. As long as you say it with authority, it is correct. As np. So now if I refer to anything as np dot something, it's going to get it from that numpy module. Okay. There's another module I'm going to want, and that's import matplotlib as plt. Now I need to run that cell. Okay, so now watch this. Theta equals 0.2, a equals np dot sine of theta, print a. So it does work now, right? Because np is taking that from the numpy module, and there is a sign there. So yay, delete that. Okay, but what I want to do is to go ahead. I'm gonna go through this in just one fell swoop. I'm going to make the damped oscillator problem from above because there is a really big difference. Let me go back to that problem over here. Because what I did was take this stuff. Let me just copy all that. I'm going to copy that and put it over here. Those are all my initial conditions. M, K, omega naught. This has to be mp dot square root because square root is not built in. Python is raised to the power is star, not hat. Beta, I'm not even sure what that is. X dot t, dt. Okay, that's all good. So let's run this. So that's my initial conditions. Now down here, what I did was I said while t is less than 0. And I went through and I used I'll give you a link to how do you solve differential equations in Python. But I'm solving this equation in Python. And I'm calculating the second derivative of x, which is x double dot, based on the equation of motion. And from that, I'm calculating the velocity x dot, and from that, I'm updating the position. And I don't want to go over those things, but I'm just saying I am doing that, okay? I'm using the time and the position to calculate the next position. And then I update time, and then I plot a data point right here. And then I go back and do it again. Now, I can't do that. There is a way to do that in Jupyter, but I'm going to do it a little bit different way, because what I want to do is actually calculate all my data and then plot it. So this one plots every data point as I get it. So let me just calculate all the data. So I'm just going to copy this stuff. I'm not going to plot the energy, I'm going to plot the position. So I'm going to copy that, and then I'm going to say, I've already got t equals 0, so I'll say while t is less than 10, do this. Okay, that's weird. Okay, these are not indented right. Okay, and why is that X red? Well, anyway, one of the things I'm going to do before that is to make a list of X and time. And once I have a list of all my values, then I can plot it. And that's what's really different about this Jupyter Notebooks. So I'm going to say XP equals an empty list. TP equals an empty list. And so the P I'm using for plot. And then down here, instead of plotting everything, what I'm going to do, weird again. Okay, something's missing. X dot equals -2 beta A minus omega 0,2 times X. Is that right? Yeah. X dot, oh, it's all shifted wrong. Maybe it goes like this. Okay. Now I'm going to add a data point to XP. So I can say XP equals XP plus X. Let's put some spaces here, just to make it look better. That adds the X value to that list. Now I'm going to add TP equals TP plus T, again adding a time value to that list. So once this is all done, I'll have a list of my X and Y values. So I can run this, nothing's going to happen. I mean, it did it, but nothing happened. Okay. But I have a list, and I can do this, like print X 10. That'll print the 10th element in the list XP, not X. So there is a number there. I didn't want to print out the whole thing because this is too big. Okay. Now I can plot it. To plot this, I'm checking my notes here because I can't remember exactly how to plot things. Okay, yeah, so I'm going to do the following. I'm going to say, remember I imported that matplotlib, that's how I make a graph. So plt.plot, and then what I want to plot, x coordinates versus y coordinates. So my x coordinate is going to be time, which is TP. My y coordinate is going to be XP. That's it. And then I would say plt.show, and then I run it. And it didn't work. Oh, this is okay, up here I have to do matplotlib.pyplot as plot. Run that. Now I'll go down here and run this. And there you go. It plotted it. Now we can add some extra things in there. I can say plt.grid. That turns on a grid. I always like the grid. That's all I have to do. I can give it, I can say plt. Is it X label or X title? I can't remember. X label. X label, and then I just say what it is, T in seconds. You can put whatever you want in there. plt.y label, I'll call this x in meters. Yeah, and that's it. Let's rerun that, and then I have a nice little graph there. So, but it is different, and you're thinking, oh, I really like animated graphs like this other stuff. You can do that, but I'm just getting for the basic stuff here. So this is the same thing I have, except I plotted the kinetic energy, which I guess we should do that. So let's just copy all this stuff, just to make it look exactly the same. You can change the color. Oh, I don't want to do it. I don't want to do it. Because I think we're okay. I think I've done enough to show how this works. And we're going to use this some more. You could write this up as a whole thing and explain what you're doing in every little cell. But that's the first start. And we're going to do some cool stuff with Jupyter. So a lot of the stuff you can do with Trinket. I still really like Trinket better. I like it better. You can even use VPython with Jupyter. I have a little trouble getting that working, still working on figuring that out, but that's enough to get you started. So hopefully that helps. If you have any questions, don't ask me because I'm still learning, but that's good for now.